All right, in P3, we're going to talk about kind of graphing. It says graphical representation of data. Graphing, plotting points, finding the midpoint, and finding the distance. So it starts with a Cartesian plane, which is a coordinate plane. Important here is to know which quadrant's which. So the upper right-hand quadrant, where x and y are both positive, is quadrant 1. And then it goes counterclockwise from there. So to the left would be quadrant 2, quadrant 3, and quadrant 4. Example 1 is just plotting points. So starting with our first point, I'll call it A. Go to the left to -1 up 2. Second point, I'll call it B. We go to the right 3 and up 4. You guys should all know how to plot points. C is the origin, 0, 0. Next point, I'll call it D. We go to the right 3, stay at 0. And then the fifth point, I'll call it E. So we go to the left to -2 and down 3. Next thing we're going to talk about is the distance formula. The distance formula is derived from the Pythagorean theorem. If I had a point, it'll be on a plane or it'll give you 2 points. We use Pythagorean theorem to find the distance of those 2 points. Important things to note for the Pythagorean theorem is that the hypotenuse has a length of c. So c is always your hypotenuse. It's always the longest side. So when you use your Pythagorean theorem, the a squared plus b squared equals c squared, c is always the longest side. So that leads us into the distance formula, which is this here. So the square root of x2 minus x1 squared plus y2 minus y1 squared, which is written again on the next page. So the distance between 2 points can be found using the distance formula. So example 3, we're going to find the distance. So I'm going to write my distance formula here. We have the square root of x2 minus x1 squared plus y2 minus y1 squared. I think it's always helpful to label the points before you plug them in. So my first point I'm going to call x1 and y1, second one x2 and y2. Then we can plug it into our distance formula. So we have 3 minus -2 squared plus 4 minus 1 squared. What's 3 minus -2? 5, so 5 squared plus 4 minus 1 is 3 squared. 5 squared, we have 25 plus 9. So this would be the square root of 34. Always simplify your radical if we can. Do we have 2 factors of 34? What are 2 factors of 34? Awesome, 17 and 2. Does 17 have any other factors? And neither does 2. So this can't be broken down anymore. So our answer would just be the square root of 34. So example 4 says, show that the points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. So let's plot the points first. I'm going to go to the right 2, up 1. Go to the right 4 and stay at 0. And then the right 5 and up 7. So here's our triangle. Now it's kind of hard to tell from here what our longest side is. It kind of looks like this side here, but let's find the lengths of each side so we can tell what our longest side is. So to find the lengths of each side, we want to do the distance formula for each point. I'm going to label my points here, so I'll call it A, B, and C. So A, B, and C. So first thing I want to do is find the distance between A and B. I want to find out the length of that side. So we're going to do the square root of, I'm going to label my points x1, y1, x2, y2, and plug it in. So we have 4 minus 2 squared plus y2 minus y1 would be 0 minus 1 squared. So 4 minus 2 would be 2. 2 squared is 4. 0 minus 1 is -1, and 1 squared is 5. I mean 1, sorry. And then 4 plus 1 would be 5. So here, our length is the square root of 5. Everybody good with that? Let's do the same thing, but we're going to find the length of CB. So we're going to find this length here, this side. So now I'm going to use my points B and C. I'm just going to call B, I'll leave it as x2, y2, but that means C has to be x1 and y1. So I could have done B as x1 and y1. The order doesn't matter, just as long as you're consistent. If I'm calling it the second point, both the x and the y have to have the 2. It has to be the second. So we're going to take the square root of x2 minus x1 would be 4 minus 5 squared plus y2 minus y1 would be 0 minus 7 squared. So 4 minus 5 would be -1, and -1 squared is 1. 0 minus 7 is -7, and -7 squared would be 49. So 1 plus 49 would be 50. So here we have the square root of 50. Can I simplify the square root of 50? I can, but this question is not asking me for just the length of BC or CB. It's asking if it's a right triangle. So because I'm not done with the work, I just may want to leave it unsimplified for now. In my final answer, I just want to simplify any radicals that I can. So I'm just going to leave it as the square root of 50 for now. Let's find the length of AC. So I'm going to call A x1, y1, and C, I'll call it x2 and y2. So x2 minus x1 would be 5 minus 2 squared plus y2 minus y1 would be 7 minus 1 squared. So 5 minus 2 is 3 squared, and 7 minus 1 is 6 squared. 3 squared would be 9, plus 6 squared is 36. This would be the square root of 45. I can also simplify the square root of 45, but I'm just going to leave it for now because it's not our final answer. We still have some work to do. So square root of 45. So now that we found the length of each side, which side's our longest one? What's the length of the longest side? Square root 50. Square root 50 is longer than square root 5 and square root 45. So in order to find out if this is a right triangle or not, we want to use Pythagorean theorem. We're going to use a squared plus b squared equals c squared. Now a and b don't matter which one's which, but c has to be our hypotenuse. It has to be the longest side. So we said square root 50 is the longest side, so that has to be our c. So I'm going to say the square root of 5 squared plus the square root of 45 squared is equal to the square root of 50 squared. Well, here the square root and the squared just cancel, so I have 5 plus 45 is equal to 50. 5 plus 45 would be 50. Does 50 equal 50? Yes. So is this a right triangle? What do we think? Yeah, it's a right triangle because when we found our sides and plugged them, or the lengths of the sides and plugged them into Pythagorean theorem, if you get a squared plus b squared equals c squared, it's true, it's a right triangle. If it didn't equal, if you had 49 equals 50 and it wasn't true, then it would be not a right triangle. So in order for it to be a right triangle, a squared plus b squared equals c squared has to be true. So yes, this is a right triangle. All right, next thing we're going to talk about is the midpoint formula. So our midpoint formula is the average of the x's and the average of the y's. So we're finding the middle of the x's and the middle of the y's. Your midpoint is always going to be a point, so your answer is going to be in a point. So we have x1 plus x2 over 2, comma, y1 plus y2 over 2. So in example 5, we're going to find the midpoint. So our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. I'm going to label my points to make it easier for us to plug in. So x1, y1, x2, y2. Labeling your points just kind of lessens the room for error. You don't have to label them, but I think it's easier once you label what's what, just to plug it in once you have your formula. Kind of just allows for less mistakes. So x1 plus x2 would be negative 5 plus 9 over 2. I'm just going to simplify this all the way, then we'll find the second point. So we have 4 over 2, and 4 over 2 would simplify to 2. Let's do the same thing with the y's. Negative 3 plus 3 over 2. This would be 0 over 2, which simplifies to 0. So our midpoint would be 2, 0. All right, in example 6, we're finding the length of a pass. So length, we want to use the distance formula. So a football quarterback throws a pass from the 28-yard line, 40 yards from the sideline. The pass is caught by a wide receiver on the 5-yard line, 20 yards from the same sideline, as shown in figure P21. How long is the pass? So we're going to use from this point to this point. And we want to find the length of it. Doesn't matter which one's my x1, y1, or my x2, y2. Which one's my first point, which one's the second one? No, doesn't matter. Just as long as you're consistent with it. So I'll call the 40, 28, x1, y1. And then my second point will be x2, y2. So my distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So 20 minus 40 squared plus y2 is 5 minus 28 squared. 20 minus 40 would be negative 20 squared, and 5 minus 28 would be negative 23 squared. So negative 20 squared would be 400. And 23 squared, you might know it off the top of your head, but I'm going to write it down. So 3 times 3 would be 9. 3 times 2 would be 6. Got to put a 0 there. 2 times 3 would be 6. And 2 times 2 is 4. So this would be 529. So we have the square root of 929. Let's see if we could simplify. Do we know if 2 goes into 929? What do you think? No, because it's an odd number. What about 3? In order to tell if 3 goes into our number, or is a factor of it, you want to add up each digit. So 9 plus 2 plus 9 would be 20. Does 3 go into 20? No. So 3 doesn't go into this. If 2 didn't go into it, 4 is not going to go into it, 6 isn't going to go into it. We could try 7. I think that might be our last possible option. Let's try 7 just in case. So 929 divided by 7. 7 goes into 9 one time. 7 goes into 22 3 times. And 7 does not go into 19. So I think 929 is a prime number. So that would be as simplified as we can go. All right, last example, example 7. We're translating points in the plane, so it gives us 3 points. And it says shift the triangle 3 units to the right and 2 units upward. So if we're going 3 units to the right, if I move along the right, so if I start at the origin, let's say, and I move 3 to the right, we're going along the x-axis. I'm increasing all of my x's by 3. So I'd add 3 to each x. So my new points would be just the x's. -1 plus 3 would be 2. 1 plus 3 is 4. And 2 plus 3 would be 5. Now let's do the same thing for the y. We're going 2 units upward. So if I were to shift 2 upward, we add 2 to the y because we're moving along the y-axis. So we're going to add 2 to all of our y's. So 2 plus 2 would be 4. -4 plus 2 is -2. And 3 plus 2 would be 5. So these would be our new points. If you wanted to shift each one and then plot your points, you could totally do it that way too. If I shifted this point 3 to the right and 2 up, my new point would be at 5, 5. Same with this. If I went 3 to the right and 2 up, my new point would be 4, -2. And if I went 3 to the right and 2 up, this point would be 2, 4. And that would be our new triangle.